Hi everyone, welcome back to Mathematics for Engineering 3 International Program เกษตรศาสตร์ University. It's me again, M. And this is the last week of the module. Okay, so guys, if you haven't watched all the videos, if you have things that you don't understand right now, just try to contact me fast, okay, and we can sort that out. Okay, so guys, in the previous videos we talked about how to solve the second order differential equations, right, when the answer are around an ordinary point, right? X equals 0 and x equals a when a is not 0. Okay, we talked about that for the two cases, and then I showed you how to solve the second order differential equation and how to find the coefficients a and b. Okay, and guys, that technique is restricted to the case when we are finding the solution around ordinary points. Okay, but not all points are ordinary. Okay, in the video before that we talked about two types of points, right? The first one is ordinary point and the other one is a singular point. Okay, so in this video, okay, actually from now until the last video, we're going to be talking about the solution around singular point. Okay, but not just any singular points. It needs to be regular singular point. Okay, it needs to be regular singular point. Okay, so in this video we're going to be talking about what regular singular points are. Okay, and how to to get to know the points first. Okay, so let's begin here. To begin the fourth section, we first talk about the problem. We want to find the solution to this equation, okay, which is the one that we have been doing before, right? X equals x0, which is a regular singular point. Okay, guys, one thing in this section we're gonna be looking at, only the case when x0 is 0. Okay, so we have only one case, which is when x equals 0. Okay, around x equals 0. We're not going to be looking at the case when x equals a. We're not going to be looking at that. Okay, however, the method used for an ordinary point in section 3, the previous section, won't work. Okay, it doesn't work. Why? Because if you remember from the previous videos, okay, the previous two videos, when we write down the conditions, right, at some point we need to let the coefficients be 0. Remember that? Okay, and we would receive one condition, which is a 0 is 0, and that means a0 is any constant, right? And then we may get 0a1 equals 0 as well, and we get a1 which is not 0 is any constant as well, and then we can find a3, a4, a5, a6, a2, blah blah blah, using the recurrence relation. Remember that? But in this section we're not gonna get that condition. We're not gonna get 0a0 equals 0, and that is the problem, because in this section what we're gonna get is this. We will see later like why we do get this. Okay, we'll see that later, but for now, just I just want you guys to know that we won't get that condition. Okay, we will need to have this condition, and this equation is in terms of r squared is called a initial equation. Okay, we'll talk about that in details later. Okay, but guys, before we talk about all of these in details, let's first look at what regular singular point is. Okay. Okay, so first let's talk about regular versus irregular singular points. Okay, so if we go back to the same differential equation, the second order differential equation here, and we know that this is called B2, right? And this is called B1, and this is called B0. Okay, and if I divide this equation by B2x, okay, I will receive that equation when Px is B1 over B2 and Qx is B0 over B2. Okay, basically I want to make the coefficient of y double prime B1. Okay, and the point x equals x0 is a regular singular point if the power of the factor 1 over x minus x0 of px is less than or equal 1. And the power of the factor 1 over x minus 0 of qx is less than or equal 2. Okay, and this is, the conjunction is and. So both of them need to be satisfied. Okay, and the points which are not regular are called irregular points. Okay, guys, I know this is quite abstract. The power of the factor, is less than or equal 1, is less than or equal 2. But we'll see that, it will be clear when you see the example. For example, let's look at, this example here. Find all the singular points of this equation and determine their types. Okay. So first, I would look at b2x, which is x minus 1 squared. Okay. And you may see that b20 is 0 and b21 is 0 as well. Okay, in that case it means that x equals 0 and x equals 1 are singular points. Okay, the rest, the other points are ordinary. Okay, this is from the previous video. We already talked about that in the previous video. Okay, when we started talking about the chapter when we begin chapter 3. Okay, sorry, section 3, the solution around the ordinary points. Okay, so right now I can say that x equals 0 and x equals 1 are singular points. And x equals 5, x equals 10, x equals 20, x equals minus 1, all those points, the other points, they are ordinary. Okay, they are ordinary points. Okay, so right now we want to say, whether or not x equals 0 is a regular singular point. Okay, so we first need to look at px, which is this guy divided by b2x. So it is 3x minus 1 divided by x minus 1 squared. And that is 3 divided by x and x minus 1. Okay, and your qx would be this guy divided by b2x, right? And that would be 3 divided by x minus 1 squared. Okay, that would be px and qx. Okay, so once we get px and qx, we need to go back to the definition. It is a regular singular point if 1 over x minus x0, the power of this factor is less than or equal 1 for px and less than or equal to for qx. So first, let's look at the point x equals 0. Okay, right now we know that x equals 0 is a singular point, right? So we want to say 1 over x minus 0. Okay, which is 1 over x. And you can see here, you have 1 over x as a factor. You have 1 over x as a factor. Okay, you have 1 over x as a factor. It probably be, more intuitive to call this x 0. Okay, and 1 over x0 will be 1 over x minus 0, which is 1 over x. And the power of 1 over x here is 1 over x to the 1. Okay, and the power of 1 over x here is 1 as well. Okay, so the power of 1 over x of p is 1 and of q is 1 as well. So it means that x equals 0 is a regular point. Okay, and if we look at the point when x equals 1, so we need to look at 1 over x minus x0, right, which is 1 over x minus 1. Okay, which is the same 1 over x minus 1. And if you see here, the power of 1 over x minus 1, the factor, as what we call factor, is 1 for p and 2 for q. As you can see here, you have 1 over x minus 1 squared. So the power of this guy is 2 for q. But it's less than or equal 1, less than or equal to for q. It means that x equals 1 is still a regular point. Okay, so for this question, to sum it up, x equals 0 and 1 are singular points. Okay, are singular points, and the rest, all other points, they are ordinary. Okay, and we find px and qx, which are the second term divided by b to x, and the third term, which is b 0x, right, divided by b to x. And then we look at the power of the factor 1 over x and 1 over x minus 1. And for p is less than 1, for q is less than 2, for p is less than 1, for q is less than 2, which means that x equals 0 and x equals 1, they are regular singular point. Okay, I forgot singular here. I should have put singular point here. Okay, so let's look at the next example, this one. This example, as you can see, b to x is x squared minus 4, which is x squared, x plus 2, and x minus 2. Right? Which means that b to 0, b to 2, and b to minus 2, they are 0. Okay, b to 0, b to 2, b to minus 2, they are 0. And that means x equals 0, 2 and minus 2 are singular points. Okay, and the other points are ordinary. Okay, the other points are ordinary. Okay, and now we want to know whether or not these points, they are regular singular points. Okay, right now we know that they are singular points, but we don't know whether or not they are regular. Okay, so we first look at px, which is the second term, 2x cubed divided by x squared minus 4, and that will be 2x divided by x squared minus 4. Okay, that will be 2x divided by x squared minus 4. And qx, that would be 3 divided by x squared minus 4. Okay, and if we look at the first point, which is x equals 0, 1 over x minus x 0, that will be 1 over x. Okay, 1 over x minus 0, so it's 1 over x. And the factor here, there is no 1 over x, right? Which means that the power of 1 over x of the factor is 0, which is less than or equal 1. And this is 1 over x squared, so it's 2, which is less than or equal to. It means that this x equals 0 is a regular point. Okay, the next point would be x equals 2. So 1 over x minus x 0 would be 1 over x minus 2. Okay, this guy is actually 2x over x plus 2 and x minus 2. Okay, this is 3 over x squared x plus 2 and x minus 2. Okay, so we have 1 over x minus 2 to the 1, right, as a factor, so which is less than or equal 1 for p. And here we have to the 1 as well, which is less than or equal 1 for q. So this point is also a regular point. Okay, and the last point is when x equals minus 2. Okay, that will be 1 over x plus 2. And we have, 1 over x plus 2 here. Okay, and that is, the power is 1. And that is less than or equal 1 for p. And here, the power is 1 as well, which is less than or equal to for q. So, this point is also a regular point. Okay, let me get you one more example. This one you need to write that down yourself. Okay, I didn't type that in. So, the question is x cubed, x minus 2 squared, x squared plus 1, y double prime, plus x squared, x minus 2, and y prime, minus 3x minus 3, y equals 0. Okay, that would be the question. And first, again, we do the same thing. We would look at b2x, right? b2x, which is x cubed, x minus 2 squared, x squared plus 1. And we know that b20 is 0, b22 is 0. And for this one, there's no critical point because x squared is always non-negative, and x squared plus 1 is always bigger or equal to 1, so it can't be 0. Okay, so we can say that x equals 0 and x equals to singular points. The other points are ordinary. Okay, I'm not going to write that down anymore. Okay, so first let's look at the px, which is x squared x minus 2 divided by x cubed x minus 2 squared x squared plus 1, and that cancel out and that cancel out, so we get 1 over x x minus 2 and x squared plus 1. Okay, that would be px. Px would be 1 over x x minus 2 and x squared plus 1, and the qx would be minus 3x minus 3 divided by x cubed x minus 2 squared and x squared plus 1. And this would be, if you want, you can pull the 3 out, so you get x minus 1, and here you get x cubed x minus 2 squared and x squared plus 1. Okay, you can't get rid of any terms, right? So from here what you can do is to look at each point. For example, x equals 0, so 1 over x minus x0 will be 1 over x minus 0, which is 1 over x. And as you can see here, the power of 1 over x for px is 1. Okay, the power of 1 over x, is a factor, the power of the factor, which is 1 over x of p is 1. But for the qx, you have this guy, which is 1 over x cubed, right? You know what I mean? So it's 1 over x cubed is the same as 1 over x cubed, which means that the power of 1 over x of q is 3. But 3 is not less than or equal to, right? From the definition, it says that if it's less than or equal 1 for p, less than or equal to for q, then it's regular. But now it's 3 for q, which is not less than or equal to, which means that x equals 0 is a irregular point. Okay, it's irregular point. Okay, and if we look at x equals 2, so 1 over x minus x0 will be 1 over x minus 2. And here, the power of 1 over x minus 2 is 1. Here, the power of 1 over x minus 2 is 2. Okay, you have like a little 2 here. See? So it's less than or equal 1, less than or equal 2. It means that x equals 2 is a regular point. Okay, so for this one, x equals 0 is a irregular point, it's not regular, and x equals 2 is regular point. Okay, so right now you know what what ordinary points are, what singular points are, right? And the singular points, they are split into regular and irregular. Okay, in this section we're going to be looking at the solution around regular points. Okay, it's around regular points. Good, so see you in the next video. We're going to be looking at how to solve the equation around regular points. See you, bye bye.